Okay, let's try to solve this integration problem. The question starts as saying that theta ranges from pi over 4 to 0, and by using this substitution, we have to solve this definite integral. So I'm going to start by transforming this integral from x to theta by using this substitution. So first I'm going to take the derivative of that substitution with respect to theta. So that means dx over d theta. So I'll write the substitution over here. X equals to sine squared theta plus 3. So dx over d theta would be 2, and then I have to take the derivative of sine squared theta. So that would be 2 sine theta times the differential of sine theta, which is going to be cosine theta. Now you can see 3 is a constant, and the derivative of a constant is 0. So I'm not going to write that. Here it will be 4 sine theta cosine theta. So then dx, instead of dx in the original integral, I can substitute 4 sine theta cosine theta d theta. So that's the transformation for the differential. Now let's look at the upper and the lower limits. So in terms of x, you have 3 and 4. And then we need to find what would be the corresponding theta values, because we are transforming from x to theta. So let's look at that. So our x values are here, and then the theta values are going to be there. So x 3. So when x equals 3, let's look what's the value for theta. So x equals 3, I'm going to substitute x equals 3 into our expression x equals to sine squared theta plus 3. So I have 3 equals to sine squared theta plus 3. And you can see the 3 cancels out. And then we have sine squared theta equals 0. So then sine theta is equal to 0. So that means, so this implies, it should be clear to you, it implies that theta is going to be 0. 0. 0. We'll put radians instead of degrees, okay? So that's going to be just 0 radians. So here it's going to be a 0. And then I'm going to look at the other limit, the upper limit, that is when x equals 4, what's the value of theta? So I'm going to again substitute in this expression. So I have a 4 here, 2 sine squared theta plus 3. So then I have 2 sine squared theta equals 1. So sine theta, you can see it's going to be plus or minus 1 over square root of 2. Okay. Now, there are two values for sine theta. So what are we going to select? So that's where we are going to use this limit, this range. So from here, since our theta is defined for this closed range of 0 and pi over 4, that means it's going to be an angle in the first quadrant from 0 to pi over 2, right? It's a small angle. So for small angles, sine theta will have a positive value, so we can neglect or disregard the negative value. So as a result, I'm going to just use the positive value 1 over square root of 2, and as a result you'll see that theta would be pi over 4, that's radians, okay? So these are all in radians. So I'm going to say 4 is going to be pi over 4. So that means for x equals 4, we have the angle in radians pi over 4. So now we are ready to substitute for our original integral. We have dx expressed in d theta. Then we can substitute for x using the original substitution, that is this one, so that our integrand will have theta, and also the limits, the lower and the upper limits have been converted from x values for theta values. So now let's write this new form, new transformation for the original integral. Okay, now let's substitute for our original expression. So the lower limit will be 0 to pi over 4, and inside the square root we have x minus 3. So if you recall, our x is written as 2 sine squared theta plus 3. So from here you can see x minus 3 is nothing but 2 sine squared theta. Okay, that's x minus 3. Because you can see, look, x minus 3, you take this 3 to the other side, so that will be minus 3, and that's equal to 2 sine squared theta. Okay, and in the denominator, you can just substitute 5 minus x. What is x? That's this value. So you have 2 sine squared theta plus 3. Okay, and then your dx is 4 sine theta cosine theta d theta. So further simplification, we'll get in the numerator 2 sine squared theta. In the denominator, we are going to get 2 minus 2 sine squared theta, and here we'll have 4 sine theta cosine theta d theta. Now let's see whether we can simplify this further. You can see inside the square root there's a 2 in the numerator and there's a common 2 in the denominator, so those 2 cancels out, and also the denominator can be written like this. We have sine squared theta, and the denominator 1 minus sine squared theta. So that's going to be a cosine squared theta. We can write it as a cosine squared theta. And then here we have a 4 sine theta cosine theta d theta. The square root of sine squared theta over cosine squared theta is going to be tangent theta, because sine squared theta over cosine squared theta, that is this one, is tangent squared theta. When you take the square root, that would be tangent theta. Okay, so further simplification, or you could even write, you should know that sine theta over cosine theta is tangent theta. So you can just write this numerator denominator form, because then one of the cosines will cancel with the other one. So we can do it like that. We'll write sine theta over cosine theta, and then we have 4 times sine theta cosine theta d theta, and look, cosine theta and cosine theta cancels out. So we are going to get, as a result, I can take out the 4 out of the integral, 0 to pi over 4. We have sine squared theta d theta. So now our integration has simplified into taking the integral of sine squared theta. So now let's see how to do this sine squared theta integration. Now, in order to do this integration, we can use the double angle identities of trigonometry. So for example, you should remember there's something called cosine 2 theta equals 1 minus 2 sine squared theta, right? So then you can see 2 sine squared theta can be written as 1 minus cosine 2 theta As a result, sine squared theta is equal to 1 half 1 minus cosine 2 theta. So we can make this substitution where now we have a double angle instead of a single angle. That means 2 theta instead of theta, and we have taken out that square term. So our integration, and you should see that this is just an identity, so there's no change in the upper and the lower limits. They are still 0 to pi over 4. And then we have 1 half 1 minus cosine 2 theta d theta. One of the 2's will cancel out, 1 half will cancel out with this 4, so you have a 2 there. So we have 2 integrate 0 to pi over 4, 1 minus cosine 2 theta d theta. Okay, so we are going to distribute the integration like this: 2 times integration from 0 to pi over 4 d theta minus 2 times again integration from 0 to pi over 4 cosine 2 theta d theta. Now when we integrate the first term, it's just theta with the upper limit of pi over 4 and the lower limit of 0 minus 2 times the integration of cosine 2 theta. So that's going to be 1 half sine 2 theta. And again we have to substitute the upper and the lower limits, pi over 4 and 0. So I'll finish this simplification over here. I have 2 pi over 4 minus 0. That's for the first term. And then for the second term, you can see the 2 and the 1 half cancels out. So that means I'll simply have sine 2 theta, where theta is pi over 4. So it will be sine pi over 2 minus sine 0. But remember that sine 0 is 0. So we get pi over 2 minus sine pi over 2 is 1. So the final answer is going to be pi over 2 minus 1. So that's the final answer for this integration.